All right, let me close all this other crap down too. Okay, so let's do this. Let's start with a, oh, come on. I hate it when this happens, when this, the screen mirroring starts freezing up. Hold up, let me pause. Pause. We were talking about the scientific method, and we were talking about how you have people, you can develop a hypothesis, but the only way to test that is to do experiments. And if you get enough experiments that give you enough data, that hypothesis can turn into a law. And if you get enough data that can be used to explain some natural phenomenon or some observance, then or observation, then it can actually become a theory. So for ivermectin, that was this hypothesis. I don't know where it came from, but that was a hypothesis that it could be used to treat COVID-19. I'll be the first one to tell you that the data and the peer-reviewed studies were very scant for ivermectin as a COVID treatment. Very scant. Only been studied in a few countries, and most of those were studies based on very limited sample size. All right, so we have this ivermectin. Now let's think about this in terms of measurements, right? A horse, how somebody give me an estimate. What do you think that horse weighs? It's pretty muscular, pretty good size. What do you think it weighs?
Like 500 pounds.
About 500. I'm gonna say
1,000 maybe,
600.
at least 1,000.
600,
'Cause
700.
That's a full grown horse. So let's say about 1,500 pounds.
Oh, they bigger than a cattle.
And this is a particular, I can't remember the breed that I Googled, but this is a particular breed, and they're very muscular, and they usually weigh about 1,500 pounds. All right. And then a human being, average man, 6 feet tall, let's say 175 pounds for the average human. That's
Hey, this is salty. I'm 180.
okay. All right. Guess what? This is why we're gonna do that. How about that? I did
That's
say
even
average,
more
though.
insulting. I'm a woman.
How about that? Now we got to come to some kind of consensus. I'm gonna say 175. I'm gonna leave it at 175. That's average. Now I am not. This is the average. This is not one particular person. This is average, about 175. All right. All right. So now we gotta think about this, because what is ivermectin? Anybody? Any animal science majors here that have actually used or applied or studied ivermectin? Anybody know what it is? What it's used for?
No, I don't think we learned it.
It's actually a dewormer. So it's an anti-parasitic compound for large mammals. Large is the key word. They have also formulated ivermectin for smaller mammals like dogs and cats. All right. So with ivermectin, if it's a large mammal anti-parasitic, we got a problem, because number one, the dosages are going to be so different for large mammals, 1,500 pound horses, as opposed to 175 pound human beings, that you got to have some way of converting, right? So for horses, we use ivermectin to treat roundworms. Again, it's an anti-parasitic. Not an antiviral, by the way. It's anti-parasitic. That's a big issue, right? Because you're trying to use a drug that has one particular mode of action against a totally different type of organism is tricky, very tricky to say the least. Uh, so it's used to treat roundworms. You can buy it as a paste. That's literally a mixture of 1.87% ivermectin and then other fillers. So what is that? 98.13% fillers. All right. And it's edible, so you administer it orally. For human beings, it does have some uses, mostly in third world countries. Let me not do that. That's too far out. I need some room. Right. It has some uses in third world countries. It's used to treat river blindness. And let me shrink this down so I can make some room. Right. It's used to treat river blindness in humans. And I'm just stay with me through this example because I'm trying to make a point. All right. So we're going to go around the corner and down the street to make the point, but I'm going to make this point so that you can understand the power and the necessity of applying scientific thought to everything and to the power of measurements. So river blindness, that's a parasitic that's the result of a parasitic infection of the black fly. So river blindness, and also it's also used to treat roundworms in humans. COVID, we don't know. Not enough information. That's just being real. I know everybody was going crazy about it, but we really don't have enough information to know what type of effect ivermectin would have on COVID-19. We just don't know that. And the reason I say that is because, again, a hypothesis with no data is nothing. It's just a thought. It's an idea. You have to back it up with data, and there's not enough data to suggest that this is a viable treatment. All right, so for human beings, we have a dose for river blindness. It's 150 micrograms, and I'm gonna pay close attention to that prefix, 150 micrograms per kilogram of body weight. So for a human being, you dose, and for animals too, you dose based on the mass of the organism, right? If it's a 1,500-pound horse, you dose per kilogram of body weight, right? So if you think about that, we think about for roundworms, actually it is 200 micrograms per kilogram of body weight for a human, for roundworms. For COVID, we have no idea, right? Because many of the studies were preliminary. There is some literature out there dealing with COVID and ivermectin, but it's very scant and it's very limited in its scope and a small sample size of people that are studied. So we don't know what the optimum dosage is. Now here's the problem, right? Here's the problem. You got somebody like Joe Rogan who's telling you, oh, I took ivermectin, or some other internet personality telling you, go get some ivermectin. How in the world are you going to know how to dose yourself if all the dosages that are out there that are reliable are for horses that weigh 1,500 pounds? And if you notice the dosages for river blindness and roundworms, there is no accepted dosage for COVID-19. So how do you dose yourself when you don't have a clue about how much of this stuff is actually going to take, right? But let's look at the measurement part, right? So we have, and that's again, you have to think scientifically. If you think in terms of science and not passion, then you won't be able to get snowed over because you're going to always ask questions, right? You're going to ask, how do you even measure a microgram? Are y'all following that? Measuring a microgram is not easy, right? It's actually impossible to do on a scale where most of the balances that we use for everyday use, it's impossible to measure. And I'm gonna show you why. So for let's take river blindness. The dosage is 150 micrograms per kilogram of body weight. First of all, in the United States, we don't measure body weight or body mass in kilograms. We measure it in pounds. So we're going to have to, first of all, convert that. Now, if you don't have any knowledge of conversions or measurements, that is virtually impossible unless you can go Google it, but many people are not even thinking on that level as far as converting this, right? But you will have to convert it, and you have to convert it based on the conversion that 1 kilogram is 2.2 pounds, right? So in order to find out how many micrograms of ivermectin you would need per pound of human being, you could simply divide that 150 micrograms divided by per kilogram divided by two. Well, let me take that back. Don't need that. Divided by 2.2 pounds, and that'll give you how many micrograms per pound. Does somebody put that in your calculator real quick and give me a number?
Or it says 68.
68.
18.
Okay. So let's go with 68. You said 68.18.
Yeah.
Yeah, so good. Let's round that up. 68.2 micrograms per pound. So that's the dosage from micrograms per pound for roundworm infection, not for COVID. We have no idea what that is literally because the data is still being collected. But what I want you to notice are some things here that we can use because this is again an introduction into measurements. Notice I have here a prefix. Micro is a prefix. Does anybody know what the prefix micro, what it stands for? You may or may not. It's okay if you don't, but I want to see if anybody does. Does anybody know what that prefix means?
Oh,
Okay, it does mean small, but this has a literal value attached to it. That prefix micro is 10 to the minus 6. That's what that means. So a microgram is 1 times 10 to the minus 6 grams, or 1 over 1 million. Hold up, sorry. Grams, 1/1,000,000th of a gram. That's how much a microgram is. Now tell me this. Do you think that there is a balance that you could order from Amazon or from wherever that can measure out a 1/1,000,000th of a gram that you can have? And the reason I ask that is because I actually have a balance here at my house because I work on some particular projects. Working with a guy who lives in Arkansas. We got a project that we're working on trying to patent, and I have a balance, but I can't weigh micrograms out on it. So do you think that this is something you can just go into Lowe's and grab a balance that allows you to do that? All right. Anybody? All right. The answer is no, you cannot. And so when someone is trying to tell me that to take ivermectin or whatever, and you can't even tell me the dose. You can't even tell me how I can get to this particular dosage. That's the safe dosage for another disease now, another infection. How in the world are we gonna know how much to take? Who's doing the measurements to take 150 micrograms of ivermectin or 68 micrograms per pound of body weight? Who's doing those measurements? All right. What you'll also notice is that there is a numerical value here. Right. The numerical quantity that's in front of that, in front of the unit is the magnitude. Right? How much of it do you have? And then what you'll notice here, and this is for any measurement, and we'll recap this in a second. But what you'll notice here is that you also have a unit of measurement. So every measurement has these these two things at least. They don't all have prefixes because sometimes you don't have a specific denomination of a unit, but you'll have at least these two things: a quantity or with magnitude, and a unit. The magnitude allows you to understand how much. All right, this tells me how much. The unit is a standard of comparison. What can I compare it to? Right? I need to know these things as a scientist. I need to know these things, right? I need to know how to measure things, get a numerical quantity, and attach some unit to it so I'll know what I'm comparing it to. Right? So when we talk about measurements, these are the things that are a part of any measurement: magnitude and a unit. Without the unit, the number is meaningless, right? It's totally meaningless. If I just put 150, I don't know what that means. So I have to have a unit in order to tell me what what magnitude I'm measuring. Am I measuring grams? Am I measuring inches? Am I measuring meters? So on and so forth. All right. Any questions? Any questions about that? Right. Let's do the other measurement. And let me add a page here, and we're gonna do the other measurement for the roundworm infection. So the dosage of ivermectin, I'm just gonna abbreviate it as IVM, for roundworms in humans is 200 micrograms per kilogram of body weight. Even though we're not doing conversions right now, it should be a lowercase k, sorry. Let's think about how would you convert that to determine how many micrograms per pound, because it does matter. Let's go back up to here. What did we do to get what conversion did we use? We used the conversion of kilograms to pounds. Is that right?
Yes, sir.
So if I wanted to take this and turn it into micrograms, I think I said kilograms to pounds. My bad. If I wanted to convert this to micrograms per pound, what do I need to do? I can take that kilograms and sub it out, right? So this would be 200 micrograms divided by how many pounds are in a kilogram? 2.2 pounds. That's my conversion. Can somebody calculate that real quick?
I got
90.
90.90 repeating.
90.9.
Not, yeah, basically.
We'll take it. 90.9 micrograms per pound. That's the dosage. Again, this is for roundworm infection. The other is for river blindness, but neither one of these correspond to an effective dosage for COVID-19. So we just don't know. But again, if this is a measurement, we see the same things, right? We see in this case, a prefix. We see a unit. Let's look at. And then we see a number. Right? Every measurement is going to have that magnitude and that unit. That actually, let's talk about that. Let me pull this up right here. There are actually 7 fundamental units in the SI system. SI is just an abbreviation for System International, or International. It's actually French, but we just call it the International System of Measurements. So let me crop this right quick. So, should have already had it cropped, my bad. All right, so we got 7 fundamental properties with base, and these are called what we call base units. Right? You have length, mass, time, temperature, which are the 4 that we're going to look at in the most detail. But then you also have current, amount, and luminous intensity, right? And so length is measured in meters, mass in kilograms, second for time, and then Kelvin for temperature, right? And then this is going to lead us into some other good stuff because there are conversion factors for all of these things, right? So if I want to convert from SI to metric, there are conversion factors that I can use to convert temperature into Celsius or Fahrenheit from Kelvin. I can convert seconds into minutes and hours. I can convert kilograms into pounds, so on and so forth, right? So when you're comparing the two systems, the international system and the metric system, there are other conversions that we're going to look at, right? So a meter is the standard for length, right? And when we say length, if we're talking about width or height, all that falls under the same thing. It's just in a different direction, right? So the length, the width, and the height are all going to be measured by the meter. And a meter is, let me switch pens. I don't like this pink. So a meter is about 39 inches, 1 meter, which is about a little bit over a yard. Right, so if you know these numbers, if you know that a meter is 39 inches or 1.09 yards, if I have yards, I can always convert to meters And if I have meters, I can always convert into yards. Let me show you. All right, let's say I have 10 yards. Trying to get a first down, right? Game is on the line, fourth quarter. I'm trying to get a first down. How many meters is that? Well, if I take this and I multiply it by my conversion, because you can make a conversion factor out of anything, right? So all you need is the two values, the equivalent values. So if I want meters, I put that in the top. 1 meter divided by, and I put what I'm trying to get rid of in the bottom. Right, 1 meter is 1.09 yards. Go ahead.
Yeah, cilantro in there.
Do y'all have like music playing when y'all cook? Do y'all play music?
Yeah, it's a very fun and
All right, somebody calculate that. It's going to be a little bit less than 9. Well, yeah, a little, maybe 9 point something.
On 0.9.
0.9.
91.
So
Yeah.
0.91 meters is 10 yards. Are you sure about that? 10 divided by 1.09. Shouldn't that be
I'm
close to
gonna
9?
divide on.
Huh? Oh, you put the top.
Yeah. Hold on, yeah. You start dividing again.
All right, so what is it? Is it 9 point something?
9.17.
9.17?
Mm-hmm.
We'll take that. So 10 yards on a football field, if you convert it into meters, is 9.17 meters, right? So if you got any two numbers and units, you can interconvert between units using what's called a conversion factor. So this right here is my conversion factor from meters to yards. And you can do this. The thing about this, you can do with anything. All you need is the two equivalent units and their numerical value. So again, let's think about this. What is, when we say yards, what is that as a part of this measurement? Is it the unit or the magnitude?
The unit.
Unit, good. That's my standard of comparison. So if I have it in yards, if I want to compare it to another quantity using another unit for length, then I need to know what I can do that, right? I'm not comparing this to time or to density or to electric current. I'm using a comparison to something else that describes length. So yards and meters both describe length, right? So that's my unit. What about the 10? What is that?
What's that bit called? The quantity.
Quantity or the magnitude. Good. Right. So anytime you have two units that measure the same thing, you can convert in between them. Right. You can convert between them. Let's think about something else that's up here, because this is going to help us to understand something for later when we talk about the amount of substance. Right. This is standard in chemistry to measure things in moles. Right. So when we think about moles, let me give you a quick and dirty discussion about that. And then we're going to go back and talk about some of the other units. All right. So think about moles. Somebody look up, and I'm just, again, I don't like, if going in order helps, wonderful. But if we move out of protocol to discuss something that comes up, that's good too. So let's think about this, because you're going to see this term moles a lot. So let's think about this. Somebody look up sodium carbonate. And look up the molecular weight. Sorry. Telemarketers don't know my schedule. Somebody look that up real quick. Molecular weight for sodium carbonate.
It's 105.9888 grams over moles.
105.99. And what was that unit again?
Grams over moles.
Good, excellent. Grams per mole. Grams per mole. Notice this is what? When you think about this measurement, what is it? What is the 105.99? Is it the quantity or is it the unit?
Quantity.
Quantity, good. And then the grams per mole is what?
Unit.
Unit. It's a derived unit. Because if we look up here, we got moles, we got kilograms, but we don't have together, grams and moles together. So grams per mole for molecular weight is what we call a derived unit. And we're going to talk more about that later. It's a derived unit. All right. So what if I said that if I had 25 grams of sodium carbonate? Now, first, let me do this. What if I just put 25 grams? Does that mean anything to you? If I just put the number 25 grams on the screen, does that mean anything to you?
No.
No, it means nothing. That can be 25 grams of hamburger meat, 25 grams of powdered sugar, 25 grams of whatever. So I need to know what I'm talking about. So it's 25 grams of sodium carbonate. All right. And let's say I wanted to know how many moles were in that. Right. There's a conversion for that. Right. So if we take grams over molecular weight, which is measured in grams per mole, that will give me moles. If I want to know the number of grams and I have moles, I can switch this around and say molecular weight times moles will give me grams. These are all unit conversions. So I can go between these units. I can go from grams to moles or moles to grams based on this one calculation right here, where I have grams over molecular weight equals moles. That unit moles right here is derived, because we said that grams per mole is a derived unit. Moles is derived from the grams of a substance over its molecular weight, divided by its molecular weight. All right. So somebody help me out. How many moles are in 25 grams of sodium carbonate? Let me shrink some of this stuff down so we can fit this calculation in here. What would I do? If I know that grams over molecular weight will give me moles, how do I calculate that?
You put the 25 grams of sodium carbonate over 1 mole of sodium carbonate.
Over one, do I put it over
Or
one
no,
mole?
you put it over the amount of mole. You put it over the 105.99 moles.
Yes. I put it over the molecular weight. And this is grams per mole, right? So the grams are going to end up canceling because this is a quotient. So it's like 1 over grams per mole. The moles are going to end up, this is going to flip because it's a quotient. So it'll be moles over grams, right? And then so the grams are going to end up canceling. So this is going to cancel here. Somebody calculate that while I'm doing that. And we're left with moles. Let me move this around. Sorry. This wouldn't happen if I was on a whiteboard. I'm gonna put this up here. All right, anybody got the calculation done yet? 25 divided by 105.99 grams per mole.
It's 0.2358.
Get my 3 right. 0.2358. What? What's the units? That's the
Moles.
important part. Moles, good. Right, so if I don't know, if I just put 0.2358 with no units, that can be anything. 0.2358 basketballs, 0.2358 gallons of gas. All right, doesn't matter. Until I put the units, that number has no meaning. And I just write it just like that. Right, but again, when we think about moles as the amount of a substance, again, we have to think about how do we get there? And we get there as it's a derived unit, right? It's grams per mole as molecular weight. And it's the grams of a substance divided by the molecular weight of a substance. All right. Let me fix this down here. Any questions? I know this was a lot. Well, it seemed like a lot.
Will we have lab today or no?
No. What I'm going to do is send an announcement and tell you what to complete, but we're not going to actually meet. So I'll send an announcement after this class, and I'll tell you what to complete for today for lab.
All right, thank you.
Any other questions? I didn't realize I was over time. I apologize for that. But the 10 o'clock class will thank you because the tech worked. So I can actually use this video and share it with them because we didn't get this far because everything just kind of timed out.